Welcome to Ask and Learn.
So in this problem, we have a car moving at 20 meters per second with a mass of 1,000 kilograms, and we want to stop that car in 10 seconds. And the problem is asking us to calculate what is the friction necessary to stop the car in 10 seconds. So first thing we need to do is calculate the momentum before you start stopping the car, and the momentum after you start stopping the car. So let's just call the initial velocity VI, the initial, 20 meters per second, and the final velocity, VF, 0 meters per second, since the car is going to be at rest. So let's calculate the momentum initial, which is going to be equal to the mass of the car multiplied by the initial velocity, which is just 1,000 kilograms multiplied by 20 meters per second. And we're going to get the initial momentum is 20,000 kilograms meters per second. The final momentum F, is going to be equal to mass of the car, 1,000, multiplied by the velocity of the car, which is 0, and we get 0 kilograms meters per second. We have to always remember these are vector quantities. So let's say that this is our axis, y-axis, and x-axis. And let's say that the car is moving towards the positive side, so we can keep this initial momentum as a positive number. And we get that, and then we have to calculate the change in momentum. So the change in momentum final minus momentum initial, so the change in momentum is going to be equal to momentum final is 0 minus momentum initial 20,000. We get negative 20,000 kilograms meters per second. Now we also know that the change in momentum is also known as impulse. So all of this is also impulse, which is going to be equal to minus 20,000 kilograms meters per second. So since we have a car going in the positive direction and we have a negative impulse making it stop, we know that the force is going to be negative. So the force is going to be pointing away from the positive x. So let's call this the friction force, F. And the friction, so then the impulse here is going to be minus F, because it's pointing to the opposite side, minus F multiplied by the duration of that force, which we also know that is minus 20,000 kilograms meters per second. So if we just equate this, we can cancel out both negatives, and the time is 10 seconds. So 10 seconds times the force is going to be equal to 20,000. We just pass the 10 to the other side, and we get that F is going to be equal to 2,000 kilograms meters per second squared, since we had seconds over here and then we passed it down dividing it, so seconds squared. But if we notice, kilograms meters per second squared is also newtons. You can get it from Newton's law, which is mass times acceleration. This is units of mass, this is units of acceleration. So we get that our final friction force is going to be equal to 2,000 newtons.